Hello everyone. So now we will start with the module 5. So in that we will start with the digital signal processors. So in that the first topic is DSP architecture. So later we will start with DSP hardware units. So now we will move on to DSP architecture. So in this DSP architecture we are going to discuss two types of architecture. One is von Neumann architecture and the second is Harvard architecture. So there we will discuss which architecture is suitable for DSP architecture. So we'll move on to the notes now. So here we start with the module 5, digital signal processors. In that first we'll start with the DSP architecture. So here, so in DSP digital signal processor architecture, so first thing, as we know that the microprocessors and microcontrollers. So here digital signal processors also have some special features comparing with microprocessors and microcontrollers. I hope you guys read about microcontrollers, and there also you know about their microcontrollers or the microprocessors uses assembly language program. Here in the digital signal processors, here we also have some special features like microprocessors and microcontrollers. So that requires some operations such as fast Fourier transforms, filtering, convolution, correlation, real-time sample-based and block-based processing. We already discussed all these types of processors or processing in previous topics. Here we have to implement them using architecture. So therefore, digital signal processors use a different dedicated hardware architectures. So there two types are there. One is von Neumann architecture and the second is Harvard architecture. So first we'll move on to this is von Neumann architecture, and here, so what is this von Neumann architecture here? So what it consists of? So it consists of one address generator, then input output devices, arithmetic unit, program control unit, program and data memory, and it has two bus, address bus and data bus. So here, so first I will tell you what is the role of each devices in this architecture. So here in this von Neumann architecture, address generator is used to generate a particular address for the input output device or for the program memory, and the second is program control unit. It is used to convert or to decode the instruction from high level to a machine level. So to decode the instruction which is written either in assembly language or high level language into machine language. Next, arithmetic unit. It is used to process the decoded instruction from the program control unit, and here it performs addition, subtraction, multiplication, division. Like this, arithmetic unit is used to perform arithmetic operations. So input output devices, it is used to connect to the external world, so that if any device, any instructions are there in the input output device, so that can be fetched from the input output devices using address and data bus. So here in shown the last one, program and data memory. Here in the von Neumann architecture, it only has one program and data memory. So therefore, so here it works on a serial fetch or serial fashion. Means at a single clock cycle, it only can execute. So it only can fetch the instruction and then it can execute serially. So once it fetches one instruction, it has to wait for the next instruction. Like nothing but if the data is present in the program memory, then first it will fetch the data from the program memory and then it should execute later. So at a single time, either it can execute or it can fetch. So one time, one operation, means it performs serial operation. So because of this, von Neumann architecture cannot be used in digital signal processor, because digital signal processor has complex operations. It needs a parallel execution and fetching the instructions. So therefore, we prefer Harvard architecture rather than Neumann architecture. So as I said, if I say one instruction, that instruction contains both opcode and operand. I hope you guys studied that in controllers, where if I take one instruction like move a comma b, I hope you guys studied this one. In move a comma b, move is an opcode, a comma b is an operand. So opcode instruction is used which operation need to be performed. Like here in the move, it says that we have to transfer the data from the register B to the register A. Here A and B are the operands. In that A is a destination, B is the source operand. So from that it is clear that this is one complete instruction. So in that opcode gives us the information about which operation it will be performed. A comma B are the operands, so it will perform that operation, that is move the data from B to the A. Similarly, you can perform add, subtraction or division, multiplication. All these depends on the opcode. Then operand performs that operation. So similarly, when it comes to the Harvard architecture, the same thing is given in this explanation. Just go through this explanation. So when it comes to the explanation here, so here also when it comes to the Harvard architecture, but here it contains the address, program control in it, input output devices. But when I compare with the program and data memory, it has separate program memory and data memory. It also includes arithmetic and logic in it. But comparing with this Neumann, here it has a separate program and data memory. So that is the one important concept in Harvard architecture, provided with program and data address separately. So from this I can say that it can fetch and execute the information or the instruction at a single time. So it can work simultaneously, and we can also call it as parallel architecture. Because of this feature, it is used in digital signal processor. Here it has another two devices. One is multiplier bar accumulator and the second is shift init. So multiplier bar accumulator, it has two separate registers, and those separate registers are used to perform a 16-bit multiplication or the accumulation, whereas shift init is used to either shift the data left or right. So we are going to discuss these two topics in the hardware topic of module 5. Okay, so this is about Harvard architecture, how it is more advanced. The only thing is that it has separate program and data memory. With respect to that, it has separate data and address memory, address data bus. Because of this, here it can fetch and execute the information parallelly or separately. Here the same thing is shown in the waveforms. In the waveform, this is the first waveform, belongs to the Neumann architecture. Here in the first cycle, it only fetch the instruction. In the next cycle, it only execute. You can say that serial execution. So here also in the next cycle, fetch and execute. So every time it waits for the next instruction, either to fetch or to execute. But when it comes to the Harvard architecture, in one cycle it will fetch, but in the second cycle it will execute. At the same time, it is capable of fetching the next instruction, which is need to be executed. So like this, again in the next cycle, execute and fetch. So like this, it can perform the operations parallelly. So this is a serial, this is parallel. So therefore, digital signal processor is used, the Harvard architecture, to perform these operations. Okay, so this is about the DSP architecture. Okay, so thank you.